Hello, everyone, and welcome to the OAUG Young Professionals Forum's June webinar. My name is Samantha Ogon, and I'm the OAUG staff liaison for the Young Professionals Forum. This call is being recorded, and you are currently on mute, but we do highly encourage you to ask questions. So if you have any questions at any time during this webinar, don't hesitate to ask them in the questions box, and we'll answer them all at the end of the presentation. Before we start the educational portion of this call, I'd like to give you an update about the OAUG Young Professionals Forum and other educational and networking opportunities that are available to you with the OAUG. So the OAUG Young Professionals Forum is here to help those who are new to their career or new to Oracle. We are focused on helping you get your career started on the right foot, build your professional network with peers and mentors, stay up to date with Oracle Applications Community, and as a place to share helpful information or a place for you to ask questions and discuss information. I'd also like to mention that the OAUG Young Professionals Forum is run by volunteers. If you'd like to get involved in the planning process, if you have an idea for a future webinar, or just general questions, please don't hesitate to email me or give me a phone call. You can find more information about our forum or how to contact us at oaug.org/YP. Or you can email membership at oaug.org to ask me questions, maybe volunteer for that webinar. On our website, we also have a survey that is available. So if you do have a suggestion, you can go in there and take the survey, give us an idea of what you're looking to maybe present or write about, some of your best practices. Or if you want to join the committee, you can do that at that website too. The OAUG is also a place that you can receive educational resources that come from users like you. So if you want to learn more after today's webinar, you can find resources on the OAUG website. We have some great OAUG e-learning sessions coming up, including the Modern Business Codes e-learning series, and that's 3 sessions long. And that's going to be taking place once a month until September. You can also find more e-learning sessions on our website under the Education and Events tab. And you can keep an eye out for the upcoming Best of Collaborate 2017 series, which will feature live webinar versions of some of the best OAUG sessions from Collaborate 17. This is free for OAUG members and is a great opportunity if you missed a session at the conference or you're unable to attend this year's you weren't able to attend this year's conference. And don't forget that we also have additional resources from the Young Professionals Forum. We've been holding webinars for a couple of years now, so you can find copies of all of our webinars, which are professional development as well as Oracle application sessions. These are on our website, and they are free for everyone. So they're recorded versions that are on our YouTube page. All right, so now let's get started with our webinar. I have Keaton Honke on the call with us. He has been a part of the OAUG Young Professionals Steering Committee since the start and is one of our board members for the OAUG. Keaton?
Thank you, Samantha. Hello, everyone, and welcome to today's webinar about how Facebook has addressed the challenge of running their finance and IT infrastructure on IPv6. So today's webinar is going to be handled by Sandarsh. Sandarsh is a database engineer at Facebook, and he's been at Facebook for over 7 years. And he and his team were tasked with managing and maintaining the business-related applications, and they also found a way to configure the applications to run on the IPv6 stack. So with that brief introduction, and while thanking Sandarsh, I'll turn it over back to you, Sandarsh, for you to kick off whenever you're ready.
Thank you, Ketan, and thank you, Samantha. Hello, everyone. My name is Sandarsh, and as Ketan said, I work for Facebook enterprise engineering team, and we are pretty much responsible for running all the enterprise applications for Facebook, which includes some vendor applications and some internally developed applications. So hand in hand, we have more than 200, 300 applications that we kind of support and manage. And so this particular session is mainly to give you a brief understanding of how we kind of enabled IPv6 capability across the organization that included even the platform that runs all the business applications. And I think I'll give you a brief introduction about what we tried, what we faced, and then go through small case study, and probably take a question at the very end. So I think the first thing is second. Okay, so first thing is why IPv6, right? This is always a question that came up everywhere, right? And I think 2 years back when we first time attended the OAUG session, we asked Oracle, will you be in position to support or address any IPv6 related issues? And a very, very blunt question we got is, why are you going for IPv6? And another one is, we have no plans to support it, right? So this was the reason. And then why we were planning for IPv6? This is what we were running out of v4 address, right? Our address spaces were full, our security zones are full, and we have so many servers that we were not able to allocate v4 addresses anymore. We are running out of v4 address, to be straightforward. Second thing is, v6 had so much of capabilities and it has so much of features, and it's been out for more than a decade, and still people were not adapting it, right? So people were leaving the old technology, which we felt was not scaling to the extent of what we were expecting. So we wanted to go in as a one of the major organization in that direction, become v6 only, and then kind of set an example to the other organizations to follow our our kind of motivation of why we do it. Second thing is, at Facebook we adopt the latest technologies. Like anything that we run is always the latest. And this v6 we went live 2 years back, and I'm presenting it today, but we were live 2 years back on a v6 only network, right? And so we want to kind of adopt technologies which we kind of believe that can scale, and we kind of have an idea of what we will be in the next few years. So we wanted to have a technology that will support our growth. So that's why I think for this session I have specifically catered the presentation to mainly consist of systems that this group will be aware. So I kind of included like e-business. We have about 40 plus development instances consisting of about 200 servers together, production, UAT, and all the developments together. We might have about 200 servers just for development. And then we have Hyperion. There's another 40-50 servers with 10 plus developments. Then we have the OBI. So we have about 30 plus Oracle related products here, and we have more, I believe, now. But roughly, then we have other vendors like Pega, Quintana, Tableau, EPIS. Like there's so many tons of enterprise products being implemented because it was solving some business case for us. Making all these applications, kind of work in one nutshell was a major, challenge. In addition to that, this IPv6 was something which was like causing, changes across every system, and there was a lot of concern, right? And then you all know, you're all familiar with SCP, SFTP, mail, LDAP, DNS, load balancer, firewall. All these components were being discussed when we spoke about IPv6, right? Everything like, how do we do this? How will this work? How will that work? This a lot of unknowns, right? So that's where we kind of listed when we said we are going IPv6 on all our network, on the entire Facebook network. They were like, so first question is like, oh, we have a common thing, right? Does Oracle support it, or does a vendor support it on support of IPv6? And most of the 95% of the time the answer we got is no, right? We don't support it. But we didn't have an option. Either we had an option to move out of Oracle or go for v6, right? So it was like we were given an instruction like, yeah, we'll go with the engineered solution. We're going to design it, or we're going to make it work, right? So Oracle supports it or not, we need to make it work. So that was the mandate we got. Then you're not just talking about products here. Now products can talk to different systems, right? Products can talk to external. Sometimes they have dependency on cloud, they have dependency on some sites from where they download files, upload files. How do they work? Will they be able to support if we send a v6 protocol? We don't know, those are unknowns, right? Then clients, right? Clients are the decisive, and clients decide whether we should send a v4 or v6 protocols. And these clients can talk to internal, talk to external. How many clients are there and how do they work? Knowing them, each one of them was very important. And this is a vast number of applications. This was a challenge, right? Then most of the time we use load balancers, right? All our systems will have load balancers. We can exactly see the traffic, kind of traffic that's coming in. But there are certain products, they don't support load balancer, native clients, right? Like SQL Plus. You directly connect to a SQL Plus. How do you measure this traffic, right? These sort of traffic. SQL Plus is one example. It's just 1% of the native clients we have. There's so many Java, Quintana, like so many clients. How will they work, right? That's an unknown. Then what to test, right? We didn't know when we enable v6 on a server or somewhere, what should we test? There was so much of confusion around them. Then expertise on v6, right? Not just enabling v6, how v6 works, how encryption works, how SCP works, how protocol exchange works. All this was a question. Another thing is when you're doing an IPv6 change, it's a global change, right? It affects developers to admins to DBAs to Unix groups to sysadmins to network, firewall, DNS. Ask me, any group gets affected when you're going IPv6. So every application or every application group within or every engineering group within a Facebook has to work together or collaborate to make it work. So this is one thing which is very easy to do at Facebook because we are a social company and we kind of collaborated so well. So which was a challenge in the beginning, but then it worked out so well. So that's why I think it was a very big project. We knew that what we are signing up was something very difficult to do, so we had to come up with a plan, right? So we took a step back and we went with a 4-step approach. What we said is, let's make sure core infrastructure is first, is all working as expected. When I say core infrastructure, it's a server or a VM like mail, DNS, NFS, LDAP, LBR, firewall, etc. These are very common minimal basics we need for us to stand up even an application on top of it, right? So these sort of things are ready to go for a v6. We kind of took that as a core infrastructure. Then next piece, what we wanted to focus is internal only applications. When I say internal only, these are like it are used by only our internal people, so there is no external dependency on that. On such applications, we have more control on testing and driving our test cases on how we want to solutionize things. It was much easier, so we took that route. 75% of our applications are internal only. Right? Then next one is the rest of the 25% was applications that are being accessed from outside or accessing outside, like if some payroll company wants to send you a data, they send it to some channel to us, right? Similarly, if we want to contact a bank, we connect to the bank and send the data. So these are external versus internal for dependency. And then finally, we wanted to, okay, based on all these outcomes and how much decision we can make, we wanted to decide whether we should go with dual or v4 only or v6 only. It's all about, can application support, can the client work, and can we work on both? Can we live on both? That decision will happen over the time. So then we kind of, when you come to the core infrastructure, when you start up the core infrastructure, you just need to make sure that server or VM is able to support both v4 and v6, right? So you cannot simply say this is only v6 only vSphere or a VM machine, then how will it talk to v4? So it should have NIC or network capability to connect to both v4 and v6. So the core infrastructure of server should have a vSphere or a console or monitoring should all be v6 aware or v4 v6 aware, right? And then DNS can resolve to both v4 and v6 A records, basically quad A records you call it. So this was one of the very, very good feature that DNS came up with. Basically, if you resolve to a specific host name in a DNS, it can resolve to both v4 and v6 address, right? And a client that contacts the DNS kind of says whether I should use v4 or v6. So based on that, DNS will return a v4 or a v6 to the client. So this is one of the very key feature, and all the DNS nowadays will support this. And next one is like mail, LDAP. All these are like called the shared services. Like mail, kind of every product uses the mail server to send email out, right? That's a basic feature we use. LDAP, authentications, and those things. So those are capable of supporting v6. Then if you're using an NFS, you all know that it's mounted to using an IP address or a host name. You need to make sure if you are dual stacked, you can support both traffic from v4 and v6, right? Because client kind of sends data to you. It can send it on a v4 channel or a v6 channel. You should be capable of supporting both v4 and v6. Then next one is important are computers, right? Computers, can they send v4, v6, or dual, sort of protocols from there? So which means you should have NIC enabled on the laptops also. So every computer within Facebook, we just made sure it's able to send traffic using both v4 and v6. Then your firewall. Firewall is all controlled by your IP address, source to target port, that's how you control it. If you have a rule for v4 address, then you need to have a rule for v6 address, and firewall should be able to support v6 address, right? So the v6 address is so complex, it can be anything, right? It's not a format, so it has special characters, it can have anything, and a lot of the code will break when you implement such things. So you want to make sure the firewall that we use is capable of supporting it. All the routers can, support this. All the Cisco or any routers you're using, Juniper, all are able to support a v6. So so we made sure core infrastructure has the capability, and we kind of worked every day to make sure this pieces work. So this is very important for us to take the next step. So next one was application that got access internal only, right? For example, most of you might be using an application, for example, OBIE or e-business suite. They are internal only. In e-business, you might have external, but OBIE, most of the places I would say internal only, right? So those applications, right, that we have more control. We can modify something and allow them to fail. We can do it in development instance, ask the user to test. So we had more visibility, right? What's happening? We can monitor the logs to see where it's failing, right? Then you exactly know OBI, who is using OBI. You can pinpoint and say these many groups are using OBI, right? Probably just by looking at the modules, you can kind of hash out 90% of the users. So basically, right, we have a well-defined access point. So we know exactly how OBI is accessed from a browser or from anything else, from DAC, Informatica. We kind of know whether the calls will come from v6 or v4 or how we can control it, right? And then most of the organizations, if you talk about IT or business applications, I think 75% is internal only. It will not be exposed to www, so you're fine. Then I think most of them are browser-based applications. Nowadays, I have not seen any command line-based interface to that extent. So I think 80% are browser-based. Some you cannot help. There are native clients like probably SQL Plus is a native client. You have Hyperion or a SmartView, or all these are like native clients. So browsers are very easy to solve and test, but native clients specifically you have to test each of the use cases. Right? Then it's about internally we have to decide about translation versus dual stack. Right? That's only because some things like some native clients cannot support v6 because when you give them an IP address that has so much of special characters in it, they break. Right? So in those cases, we need to make sure such clients won't get a v6 address when they request a connection. So we have to give it a translator, basically a thing that will send them a v4 address, and when they send a connection, we forward it to a v6 address. But client will not be aware about that. So these are called, there are various translators you can implement using an LBR or using a simple proxy. And the next one is outside applications, right? So outside applications were very interesting, like partner applications. Like for example, if you take a bank sites, the XXX bank, they don't even support v6. If you send them a v6 traffic, they just send you a reset, right? don't even respond. And if you ask them, can you please enable V6 on that? That's not going to happen in next 6 months or a year, right? It might happen. They want to move to the latest technology, but down the line, they need at least 2 years to make that change. But these are like very, very big challenge for us. Second thing is when you send a traffic on V4, you go through one set of NAT IPs, right? Similarly, when you send it on a V6 NIC, your NAT will change. If someone has done a whitelisting based on your NAT, that is one of the security feature, it's going to break, right? So we need to see, and if we are sending your traffic on a V6 NAT, can the client add a V6 address to their, whitelisting? Some of them doesn't support because V6 address had special characters in it. Then similarly, yeah, any banks, cloud instance, or anything you connect, can they support V6 was a question, right? If not, how do we make? If they're not supporting V6, how do we make it work for external? This is the biggest challenge because internal we had a lot of control and we had a lot of engineering, experience to modify and hack the solution. But outside we didn't have much control. There were certain companies that kind of worked with us, partnered with us to even they wanted to go V6 route, and they kind of worked with us and made it work, but very, very, very less, I would say, like probably 30-40% only did that. So again, yeah, same thing about should we go dual or should we go V4 only, V6 only is always a question that lingered around for a while in the project when we started on that, right? Sometimes application is cannot support V6. Even vendor is not supporting anyways. But if you go and modify something and you put an host name that returns V4 and V6 address, it's failing. And if you put only V6 address, it's failing. It cannot. And if you put only V4 address IP, it comes up fine. These are application design flaws, which were a practice once upon a time. But I think as the technology advanced, these are, you call it, primitive or legacy products that needs overhaul or changes. And then some of the clients are so old school, like Java clients, which were written 10 years back. They work well for the developers, but they cannot live with the technology. They cannot support V6, right? Some of the applications had hard-coded V4 addresses. Cannot do anything with that, right? For example, EBS FND nodes has a hard-coded IP address. What will you do? When you enable V6, how will you replace that value? You cannot do much, right? So in this case, what should we do? Should we go V6 only or can we go dual, right? And then load balancer capability was a key. Load balancers can do a translation for you. If you send a traffic in V4, it can translate it to V6, or you can do any traffic V4 or V6, it can translate it to anything V4 or V6, right? As well as it has capability to route the traffic. If your client is requesting for a V6, then it can route you to a V6 address : port. And if it is a V4, it's a V4, it can route it to V4 address : port. That's a new features in every load balancer nowadays has. And then DNS should be capable of returning both V4 and V6 when I request, and I will decide whether I will take V4 or V6. That is the capability of dual stacking, right? So what should be returned by default is there should be a V4 or a V6 to start with. That you can decide, and you can kind of configure the DNS to do that. So if in a nutshell, right, if you look at an application architecture, this is how a basic application works. A client, call it a browser or call it a SQL+, makes a connection to a specific host. That host or an IP, if it is an IP, you should not be using an IP. In our IPv6 world, use only the host name. And DNS will say, okay, this host resolves to this IP, right? Now, for example, I return a IP, say client is only V6 capable, V4 capable, then it gets a V4 IP address. It goes to the firewall. Firewall says, okay, this you can connect this IP to this particular destination. When it comes, after it crosses the firewall, it reaches the host, which could be a VMware or vSphere. Inside the host, you have host : port, right? That is host. Some of the OS utilities will also be functioning there, the network utilities. And then you have the applications, you reach the application, right? And then client will start communicating with the application. So what client asks for a protocol, if it's a V4 or V6, based on that application should serve the request, right? Now, at the same time, the server could be, or the application could be communicating to an LDAP or an email, and that protocol is v4 or v6. That all depends on how that particular server is making that call, right? Then you again have storage, NFS, right? How did you mount your NFS? Using an IP address or using a host name? What is that storage? And then similarly, that machine might be connected to an external, right? It could be an FTP or a www or wget, support.oracle.com or anything, right? Quite possible. So this is in a very basic, these are the complexities that you will remember just to look at an application, right? And these are the main areas that we will kind of focus for any application. This, if I say 25 factors, of which these are the top 10 factors that has to be, you know, working well. Now see, the client flow, like I said before, if a client asks for a v4, then DNS returns a v4 address for a host. Firewall will do a check for the v4 address. Then it can reach a LBR, which will serve you a v4 traffic. Then LBR will forward you to an app with a v4 traffic. So if you do a PS and C, or do a netstat and C, then you can see exactly where your application is listening. Is it listening on a v4 or a v6? You can just look at the NIC card, right? Or if you do a TCP dump, you'll see that. And then from application might make a call to, you know, FTP, right? So that is, application will decide whether it's making a v4 or v6. Now similarly, v6 also similar. If you are making a v6, DNS has to return v6, firewall should resort to v6, application VIP should have a v6, and then, you know, FTP. Now if you do a dual stack, that's where the, you know, what we were trying the solution is. Dual stack, when you do it, if a client makes a v4, then DNS returns v4. If not, DNS returns v6. So it all depends on the client decision. And the firewall, if based on whether v4 or v6, it should resolve. So which means firewall should have rules for both v4 and v6, right? Then app should be able to cope with your dual stack, right? So app should listen on IP address, v4 IP address colon port or v6 address colon port. If it cannot do that, then you need to put a load balancer and a translator in between, right, to support this particular architecture. And then native FTP, you can, it all depends on what you're connecting or whom you're contacting, right? This FTP. So that definitely, you know, I'll discuss about that FTP as we go into the slide. That was one of the major issues we had. So see, decision to go dual stack is like, yeah, like I said, client is the one who determines whether you should go for v4 or v6. So whatever configuration you do with the application, client has to support it. So client is a key factor. So going v6 only was not a solution because we didn't have much control on the clients that other vendors will build, right? Then applications had hard-coded v4. So applications needed v4 to be present on the server. Going v6 only, the applications will fail. They needed v4 address within them, and you know, they can live in congestion with a v6 address. So that's where dual stack, you know, was one of the very, we thought like it's a must for, you know, application to run. Then LBR is capable of supporting both v4 and v6. So that is another reason, because if a traffic is coming from v4, let's send it to v4 end. If not, we send it to v6 end or translate it, right? Then clients were all web-based, and you know, they were able to support both v4 and v6. When you looked at clients like SQL Players or SQL Developer, or you know, for that example, in Java, you know, Quintana, Workbench, all were capable of supporting v4 or v6, right? You just need to, if your laptop has a, you know, v6 NIC and this is enabled and set as default, then it sends a traffic on v6. It had no problem. Then see, and other thing is, not every application is ready to run on v6. If a DNS returns 2 values for a particular host name, it needs to fail, right? It gets confused, right? Why am I getting 2? Right? This is design flaws. So sometimes we had to run them only on one v4 address. Right? So in that case, dual stacking was done at the load balancer level, so that, you know, underneath the application remains on v4. So again, yeah, there are a few more things. If you see at the DNS, if you look at this example, if you do a host command on a specific domain name for specific server name, it returns 2 values for you. So first one is V6, first one is V4 and V6. This means DNS by default returns V4 and then V6. The client can say which one it wants, right? It can take V4 or V6. So that is a DNS enhancement which is very much key for you to enable DualStack. Then firewall was able to support both V4 and V6. So we had rules for V4, we had rules for V6. So all the Caprica rules or any firewall, whichever firewall you're using, they should have both V4 and V6 routing groups. And then LBR has V6, similar to what DNS should, LBR should have that. Right? LBR capability to convert V4 to V6 and V6 to V4 was important. Then client request can run on both V4 and V6. So a lot of the clients that we tested were able to run on DualStack, right? Although internally they might be using sometimes V4, sometimes V6, we don't have to bother much, but at least they can work with dual. If you make it V6 only, they stopped working, and we knew about this. So this kind of was a driving factor for us to go V6. Right? So that's why I just this is kind of a very large or a very in-depth topic to talk because we did a lot of work in the background, so it's very hard to cover in a PPT. But I still want to kind of give you an example of one of the applications that we did, which this group is more familiar, right? Let's take an example of Oracle EBS, right? If you go read the document for Oracle EBS, first thing they ask you when you're installing is disable IPv6. Just make sure IPv6 is not enabled on your machine, right? Most of the documents say that. So we knew Oracle is not going to support it, and that's part of what we signed up for. And so we decided to go and do it ourselves. So some of the negatives, what were stopping us from, and what were concerning us was FND nodes table has V4 address, V4 IP address. Right? Defeats the purpose, right? Ideally, you should have a host name. You're having a IP address. Okay, that's a bad thing. Then there is a lot of, if you go cloning scripts, if you look at some of the config files, all has IP address in them. That's a bad. Then some of the clients like forms, 10G forms, those are so primitive that we don't know, right? The SQL plus some of the 10G SQLs, or if you're using 816, 817, like so primitive they cannot support, and we didn't know how they will behave. How do we cover all the test cases? And scan listeners on the rack side was not capable of supporting V6 2 years back, right? Now, I think it was the first place where Oracle kind of signed up to solve this, and they kind of resolved it in, I think, a year back. But when we were doing this project, they were not ready to support it, and we had to come up with a solution on how to support a scan listener to work on V6, right? Another thing is EBS not certified. Yes, anyway, that's sometimes Oracle will say will not support this unsupported configuration. So we kind of pay a lot for such enterprise applications, and we wanted to think through what will happen if they don't support it. And the positives were all the requests. For example, for e-business, you always go with hostname :8000, right? Like you access it through a browser, and there is only one entry point, which is your OHS or web host, right? If you enable that OHS to support V4 and V6, you kind of solved it basically, right? Your server is running with DualStack, and your application can support traffic from both V4 and V6. Will kind of give us confidence that anyone who accesses it through a browser will work. Right? Then DB connections will always come to a listener, DB listener. We know that. So if we enable listener to support both V4 and V6, that's sufficient for all the client connections. So there are only two entry points for this application. One is listener, other one is through the OHS. That is our HTTP URL or HTTPS URL, whatever you use. Right? Then now, like I said, FND nodes has IP hard-coded. Some of the cloning script has IPs hard-coded. But good thing is these are all not client-facing applications. Concurrent managers are not client-facing. Concurrent managers are within the server. They talk to each other through the IP address within themselves. They don't. So none of the users will be aware about these applications, right? How they function. So that's a good thing actually. So we can play around, or we can do so many things, without user knowledge, which is actually a good part. Then I think Oracle also released a documentation about enabling, e-business to support, DualStack. That is basically kind of put a OHS to route the traffic for a 12.1.3 system. But we were 12.2, we already had a OHS. So if you look for IPv6 support on Oracle documentation, they have a translator just to, apply. So that's a positive. So there are like 50% of the things will work, we knew just by looking at the architecture, but some of the 50% was unknown. So we enabled it. We went for IPv6. We started running all our applications within the server on both v4 and v6 address. It worked, right? So servers for DualStack. If you log in, you can connect to a server using a v4 address or a v6 address. That's your call. So all the applications running on that, which client serving applications, are dual-stacked. The DB listener is dual-stacked. The good thing is Oracle doesn't support it, but if you run your listener on a host name, it can serve both v4 and v6 traffic. That magically works. When we tested it, it was working. And if you look at the listener log, you can see traffic coming from both v4 and v6 address. That was like a very supportive of what we were trying to do, and Oracle kind of acknowledged it, saying that, oh yeah, it works, it's good for you. Then user experience, it never changed. It was always better. The performance was much more better than what we saw in v4, right? v6 was better, right? But there were issues. After we enabled v6 on our lower environments, we had more issues, right? So basically, if you're calling, say, one bank account, xxx.bank.com in FTP using a host name, our servers were sending v6 traffic, because by default it is v6 by priority. If v6 is not there, then v4. v4 is a second priority within the server. We had set it up. So when we make a connection, the FTPs were failing, because usually we wait for like 20 milliseconds. First we send a v6 header. If it doesn't respond, then we send a v4 header. It takes around 20 milliseconds, but FTP was so sensitive that it used to do a reset or failed. So what was the solution? So we had to, rather than using a host name to connect to a bank, we had to use the IP address. Not a good practice, but bank is not ready to support v6. So for now, we'll send a traffic. So this is why, client decides what should be the nature of the traffic. So when you use a v4 IP address to connect to a target, you're explicitly saying, I need a v6 only traffic. I'm sending the traffic as a v4 only, sorry. And then the client should also accept as v4. So all the banks that were not ready to support, we use the v4 IP address, right? Then DR sync was slow. So the false server, false client, were slow when you use the host name. The reason is because it was trying to send when it sends it in a host name, it receives a small reset and then it sends the packet to v4. It was working. So this small reset, if you look at the TCP dump and look at the network packets lost, we could see a huge packet losses happening. So one of the solution was to put v4 IP address in the false server, false client configuration, or your remote server configuration, or make v4 as a default protocol from the DNS, so that you don't get a reset. So either solutions will work. Then there are some applications, funny applications, that do a license verification based on a host IP address. So basically, when you install an application, it uses the host address of a particular server for the licensing. The reason they do it is because if you copy over this application to another server, it should not work, right? Which is good for them to kind of get money when you license the product. But with this DNS returning two values, this application was getting confused, right? So we had to work through our ways on how we can make it work, disable this. So then some of the legacy clients, like if you're connecting to, if you're using an old client like a Java-based client, it did not work well on a dual stack system. So we had to work through our ways. Some of the clients we just, they supported it. We said no. People are using it because we were allowing it, so we said no, and we had to shut them down. Some of the clients we had to rewrite it, right? So wherever they were using, IP address, we had to make them to use host name, and then it started working. Then, like I said, by default, our DNS was returning v6. If the endpoint is not capable of accepting V6, then we used to default you to V4. It used to take a very small, 10 milliseconds in the very beginning, but then we reduced that to still further. This one, yeah, utilities like SSH, SFTP, all these were very sensitive. They used to go reset, right? And then all the utilities like ping and host and all these commands started, network and all these commands started failing. For example, ping on V4 is ping 6 on V6. So you have to use ping 6 if your host is V6. So this was a learning as we went in, right? So I think, yeah, this is kind of a learning, and we were like, yeah, no, everything worked perfectly, right? There were minor issues, but not to the extent what we expected. So it's like, how did we do it? Like such a massive project, we just completed it in a very short span of time. How did we do it? It's basically what we did is first all the infra components were dual stacked. Just go, make everything dual stack. Let's see what happens. So on the development, we enabled all the applications to support dual stack, and we made it IPv6 v4. Then what we did is we made all our tester development environments to dual stack and configure it on dual stack. A simple example is say WebLogic. If you run it on a host name, it only binds to a v4 address or a v6 address. If you want to make it dual stack, remove the host name from your config.xml. As simple as it is. When you remove that host name and the host name is left blank, it binds to the local address, which is v4 and v6. Right? So those are some of the hackings we did, not supported by Oracle, but it works. And I think, yeah, if it works, and it's been working for us for 2 years, and it has not created any issues. Then once the development was configured to run on dual stack, we allowed it to run for next 2 months, and then we were figuring out and facing out all the issues that we faced. Then we enabled it on UAT and other testing environments where users are using the system. We did it in the background, and the users kept using it. Any issues, any log messages we captured, and we fixed it. And then kind of, yeah, we got a confidence of production. And production was so smooth, we just enabled dual stack, or we enabled IPv6 on all the systems in less than 3 hours. So that's how much confidence we had when we were going. And then this is what our journey is all about, right? Currently, we are running on all the systems on dual stack or IPv6 only, right? And we kind of, from past few months, we have stopped using IPv4 at all. We are only v6 only. So all our systems, all our vendor applications that come in are v6 only. So when we select a vendor, we say you should support v6. If they say don't support v6, then it will not work. And if they're okay to work with us on modifying and making it work on v6, then we onboard them, or else no to such applications, right? Then with our journey, yeah, it's been 2 years, no major issues reported, or no issues if you ask me. From past 1.5 years, I have not heard any issues related to this, and we are running on v6 only, which is not supported by vendor, but it all works very well. Then now v6 is a norm. Before v6 was an unknown. Now everyone just talks v6. No one cares about v4, and people, if you say v4, you're like old school. v6 is the latest. So nowadays it's part of our everyday work where we only use v6. Then so our entire project took about 6 months. So we had about 37 major vendor production applications that we dual stacked it, right? And altogether, I think these are vendor applications, but dependent systems and everything, these are just business applications that I'm talking about. Altogether, we did more about 300, but this took about 6 months to execute it. Right? First 3 months was, we kind of faced it in such a way that first 1 month is only infrastructure, next 2 months is only applications, then UAT and production. So I think all the changes were kind of done in 4 months. We were ready, but we kind of gave the system to bake itself, and we gave 2 months extra time to just to make sure everything is working fine, and then we went live. So this is how this major project was executed, and pretty much it works so well. And v6, and now we have seen a lot of companies adopting v6 because we kind of ask outside companies to send us traffic in v6, and when we say we are supporting v6 only, we can see a very general tendency of other people also wants to use this and make sure they also work. So recently there's so many companies. Even Google kind of went V6 only. LinkedIn is going. Major companies have gone in this route, and I think we were very happy to say that we kind of reached there, doing a very first few, in the list. So that's pretty much. It's a very pale topic, I can understand, but definitely this is the next technology that will get adopted by all the companies, because now we talk about not 100 server, not 1,000 server. We talk about probably millions of servers, because cloud is picking up, right? And you cannot just run on a cloud with a V4 address. It's not possible. So you need a V6. And the internet is so vast. Internet has already adopted, www has already adopted V6 to some extent. I think every enterprise, I think, either has to adopt or will be, required to adopt V6, because that's the way to go. So, but again, with that, I think I will close this session and definitely be ready to, answer any questions you have.
Thank you for presenting. I think we all learned a lot in this session. If you guys do have any questions, please type them into the questions box right now. This is a good opportunity to get a live answer too. And we'll just give people a little bit of time to write any questions they may have.
Sure, Aman. And I think, feel free to email your questions, because I know this is a very big topic, but I would definitely be very, keen to answer any questions you have. You can always send a note to Samantha, and she can forward it to me. I can answer it.
So while we're waiting on others to ask any questions, Sandesh, I had a couple, if you don't mind.
Yeah, sure.
The first one was, obviously you took about 6 months to do the entire conversion, right from design, development, your testing, and then going live. When you went live with your different applications, did you have like a staggered approach where you took a block of applications, you enabled them over a weekend, and then converted them, and then did the rest over the next few weeks, or how did you manage your production cutover?
That's a good question, Ketan. See, the problem we had is if we are not going big bang, if we are going system by system, every system was talking to each other, right? It was a very big challenge. If I enable V6 on one system and leave the other systems, then they cannot talk to each other, right? Because it's about technology mismatch, right? So the only option we had is to go big bang on everything, right? So when we went in a phased approach for, say, infrastructure piece, we went in as a first phase, right? That was you can say, first phase was infrastructure. That was independent. And then we went for all applications, right? All 37 applications in one day, right?
Oh, wow.
And the scale was automation. Definitely, if we are doing anything manually, it would not have worked. So it's all automated process that we followed, yeah.
So you obviously lined up the administrators for each of these applications to get that coordinated task of converting all of them.
Correct.
Okay. The other question I had was, do you have anything on the cloud, meaning outside of your network? Like, do you have anything on AWS or Azure or anything like that? And if so, how did you address those kind of servers and applications?
That's correct. So I was telling, see, we as a company don't have anything on the cloud, because we are a big cloud by birth. We are we have servers on the cloud. But some of the applications, like if OSN, right? Oracle OSN, they live on Amazon Cloud, right? They live on Amazon Cloud, right? And when you connect to a specific host, a client was driving whether I should use V4 or V6. For example, if you connect to a bank, I think I would take a Bank of America as a famous name. You use their FTP site to connect, right? When you use their FTP site, our client kind of says whether I need V4 or V6, right? So this is where the failure started happening, and Bank of America was not ready to support V6. So we had to use IP address, V4 IP address, to force V4 calls only, right? For Amazon, Amazon was ready to support V6. So OSN started working without any issues because OSN, all we had to do is open up V6 firewall rules to connect to OSN, right? When we enabled V6, instead of sending V4 traffic, we started sending V6 traffic. Firewall was blocking that, so we had to open up firewall rules to, contact OSN on a V6 address. So we had to work with Oracle on getting all the V6 address for their underneath, the AWS hosts, and then add those in our firewall rules, right? And then I think we had another company was like Workday, right? Workday was not able to contact us, so we had to give them a DualStack endpoint through which they can enter and do a translation from them, right? These are like they connecting to us. So I think it's a blender of applications, but that's where I was telling like external facing versus internal facing. So that's where we kind of segregated them. So
okay.
Yeah.
And the external facing, did that include all of your servers on which you're running Facebook, which is the external facing application too?
Yeah, those are V6 only. They went ahead. See, that is the main driving factor. Where we run Facebook.com is all V6 only. So they were not capable of sending V4 traffic at all. And the day they migrated, they cannot send traffic to our system because we don't support V6, right? And our problem was we cannot, our customers or banks cannot support V6. So we enabling V6 only will fail us on the other side. So that's why we went DualStack. When we made DualStack, our Facebook.com can talk to us, which was V6 only, right? And then we can talk to bank, which is V4 only. So, yeah, that was the main factor because Facebook.com ran out of IP address, right? So we didn't have IP address, so we were going IPv6 allocations only.
Yeah. So this was in a way, it was a kind of a forced change on you.
Yeah, it was a go. It was kind of forced change, but I think they planned it very well. They kind of gave us like, so in next 2 years this is going to happen. You have to go on now. So that's how they lined it up.
Yeah. Congratulations. Look like you all did a lot of hard work and you're seeing the benefit of that change. So that's great news.
Thank you. And yeah, definitely. I think there's a lot of benefit going V6. It looks very cloudy, but it's not that complicated. That's what we want to share here, right?
Right.
And yeah, anyone wants to go for V6, do contact us. We would be, we would love to help you on that.
That's great. That's great. Samantha, I don't have any other questions. Do you have any from the question box?
Hold on one second. There is one just adding regarding the V6 addresses into firewall, what if the destination vendor firewall only accepts version 4, V4, sorry.
I think that's a good question. See, if your vendor firewall accepts only V4, then force our client to send only V4. So what you do is when you connect to the vendor, you use IPv4 IP address. Don't use a host name, right? If you do that, you're making sure you send traffic only using a V4 protocol. So your firewall will do a filtering and says, okay, you're trying to connect on a V4 NIC to this V4 address, it allows you. When you use host name, then DNS will decide whether you should use V4 or V6 based on your supportability, and then your firewall will get blocked, right? So that's where, simple example, if like Bank of America is supporting only V4 and their firewall will only have V4 filters. So you have to connect to them using a V4 IP address, right? Or any vendor for that matter. Bank is one example I took, but yeah, we don't use that bank. It's just an example.
All right, so that was our last question. But again, if anyone on this call does have any future questions after they've thought about it a little bit longer, don't hesitate to reach out to me. My email is on the screen right now, and I will send it forward so that we can help get any of those questions answered. I will also be posting a copy of this webinar on the Young Professionals page. Again, that's oaug.org/YP. And it'll be on our YouTube page as well. So if you weren't able to jot down some things, I'll be posting a copy there. Otherwise, I just want to thank you for sharing your knowledge and your experience, your journey with so thank you so much for taking the time out of your day to share with us today.
Okay. Thank you, Amanda, and thank you, everyone, and Ketan. Thank you.
Thanks, Sandesh. Bye-bye.